Hello, welcome to Cognos Education, and today we're going to be talking about the real number system and properties. So first, we have our types of numbers. First, we have natural numbers, which are numbers that range from 1, 2, 3, and so on. This doesn't include 0, so there's no 0 in this, and these are just your normal counting numbers, no decimals, just 1, 2, 3, 4, 5, 6, so on. These are just your regular counting numbers. Then we have whole numbers, which is pretty much the same thing as this, but with a 0. So you have all of these, your counting numbers. 1, 2, 3, 4, 5, 6, no decimals, no zeros repeating, but this time you do have a 0. And just again, both of these go on to infinity. And then we have our integers, which are both of these. They include 0, they include all the natural numbers, all the whole numbers, but they also include the negative ones. So like -2, -1, 0, 1, 2, so on. And there's an infinite amount of these. Sorry, that was a horrible infinity sign. Yeah, just imagine that's an infinity sign. And now we move on to, first we have rational numbers. Now, I'm gonna be basic with this definition. Numbers that can be expressed as a quotient of two integers. And basically what that is saying is that we have P over Q, which will be our rational number. P has to be an integer, which means it has to be no, doesn't can't have a decimal, but can be anywhere from the negatives ranging all the way to the positives. You know, you're counting numbers, but including the negatives and also including the 0 right here. And Q also has to have the same properties for R to be rational. For example, we have something like 1/3, 0.33 repeating. So usually if something has, not usually, all the time, if something has a repeating decimal, so here 7/4 is repeating, then it's rational because it can be expressed as a fraction. Also, whole numbers are fractions, perfect squares are not fractions, sorry, rational. Okay, next we have the opposite, rational, e, um, I'm sorry, irrational numbers. These are, oh, also q cannot equal 0. So I'm sorry, going back to this cannot equal 0 because then we divide by 0 and that's not possible. So yeah, also anything with the terminating decimals. So 3.0.34 and it just ends there, doesn't go on forever. That's rational. Okay. Next for irrational numbers cannot be expressed say quotient of two integers. So I'm not gonna write down a lot of stuff like I did here, but because it's the opposite of this one, I'm just gonna write down examples. Square root of 2. This is, I don't know, if well, 1.41 something going on forever. It's irrational. It never ends. It's irrational is something that's I like just confusing because this never ends. We don't have an exact definitive value for this. And then we have pi 3.14, just never ending. And 0.7329813, just going on forever. Also irrational. No pattern. And then now we have some properties. So first we have, oh, also one more thing, real numbers. This is just all, sorry, all rational and irrational numbers combined. Pretty self-explanatory, I would assume. Well, now we're going to move on to some properties. So properties and things. So we have absolute value of x, aka absolute value. The distance from x to 0 on the number line. And we're talking about distance. So not final position minus initial position, which is displacement. We're talking about just distance, how far away it is, the magnitude of it. So it's always, well, it's always greater than or equal to 0. And so if absolute value, so let's just say absolute value of a is just a. I mean, it's a far away from 0. Absolute value of negative a is also a. So that's just some properties to know. And then we have some properties. We have commutative property. And this just says that we have, if we have a plus b plus a. Oh, so when you have a plus b, it's the same thing as b plus a. When you have a times b, it's the same thing as b times a. It's just saying when we have addition and multiplication, you can rearrange and it stays the same. And we have associative property, says a plus b plus c equals a plus b plus c. So when you add the sum of a plus b add c to the sum of a plus b. So you do this first, then you plus add c to it. It's the same thing as doing the same thing, uh, but with b plus c and then adding a to it. And then this all is just the same thing as a plus b, c, and yeah. And so then you can, oh, this also works with multiplication, is a times b, and then all of that times c is the same thing as a times product of b and c. And this, of course, is just a times b times c again. Then we have here where the distributive property. So we have a times b plus c. What you can do is you distribute the a to each term. So it's equal to ab plus a times c. This is just a times b plus a times c. So look, we can distribute it. And then we have identity properties, which are just a plus 0 equals a, and that a times 1 is also equal to a. So here we're adding nothing to a, it's just a. And here we have 1 of a, it's just a. And then for our last property, we have inverse properties. And we have a plus negative a, which you have, and you have a. Let's say a is 1, you have 1. You add the negative of it, so just minus 1. You just end up with 0. And then also if you have a times 1 over a, where a is not equal to 0, because then we have 0 in the denominator, that doesn't work, is, well, you just get a over a times 1 is a, then divided by a, that's just 1. Like, let's say you have 5 divided by 5, that's 1. Anything divided by itself, as long as it's not 0, is just 1. Okay. So that's it for, I'd say, the notes and the review for some of you. Now we have the examples, so classify. I'm sorry if the spelling for some of these is wrong. Each number as a natural, oops, my apologies, this thing always does this. As a natural, where were we? Whole or integer. Oh my, I'm sorry. As a natural, whole, integer, rational, or irrational. And our numbers are -7, 0, square root of 5. We have 3/4. We 2.333 repeating. So -7, technically there's multiple answers for some of these. I'll write down all the answers, but -7 could be, it has to be rational. Here, let me write these out. Rational, integer, and then 0 is whole number, integer, square root of 5. Now this square root of 5, we know square root of 4 is 2, square root of 9 is 3. We don't have anything square root of 5, so that's a nasty number. And those nasty numbers we call irrational. 3/4, it's a fraction. Can be, it's a fraction. 3/4 if you went ahead and solved it, 0.75. That's not a natural whole or integer because it's a decimal, but it's rational. It's literally given to us expressed as a fraction. Oh, sorry, my mic died for a second. Okay. So it's literally given to us as a fraction, so it's rational. We have 2.33 repeating. So we already know this has a decimal. So it obviously isn't rational, of course. So, I mean, no, I'm sorry, I'm so sorry. It's given to us with the decimal, so it is a natural whole or integer, but has a repeating. And if we go, well, let's not go back to our notes, but we know that anything with a decimal that repeats or terminates is rational. So this term is rational. Okay, that was example problem number 1. Now we have number 2. We have simplify. So this one is I'd say is easy. Absolute value of 15. How far away from is -15 from 0? It's just 15 away. You add 15, it becomes 0. Well, also we have this negative absolute value of -a is just a, so we just get 15, 8. Its absolute value of 8 is just 8. Now, this one is where some people mess up. Some people might cross out the negative signs, but let's first focus on the absolute value. Absolute value of -3 following this rule is equal to 3. So we have -3. So the negative actually stays. So we get 15 plus 8, which is 23, and then -3, which is equal to 20. And so our third problem, name the property times x plus 4. Now this one, you can see it. They distributed the 5 times x, so 5x plus 5 times 4 plus 20, which is the same thing as this. So it's distributive property. And now this one's probably takes a bit longer. So that just means number. Sorry, I'm lazy. Place the following on a number line and order from, sorry, from least to greatest. We have -2.5, square root of 3, -1 half, 2, and -3. Okay, so for some of these, -1 half, -0.5, 2 just stays the same. Square root of 3. Now, look, square root of 4 is equal to 2. Square root of 1 is equal to 1. So what we can do is we can say this number, since this number is between these squares, the output is in between these values. So it's, I'll just call this, yeah, square root of 3 is less than 2, but bigger than 1. So it's somewhere in the middle. So is less than 1, but greater than, did I mess these up? Oh, no. It's greater than 1, but less than 2. Yeah. Okay, and so now when we draw out our number line, we have our absolute lowest point. Let's see out of these. So we know this is between 1 and 2. That's positive. We have negative numbers in here. -0.5. That's if our middle 0 is right here, then that's somewhere here. As we get into the negative numbers, the more negative, aka the more smaller they are, the more to the left we go. Because with the positive numbers, the bigger, like, the bigger they get, the more we increase to the right. The smaller they get, the more we increase to the left. But here, the numerical value is increasing, but then we have that negative, right? So it's, yeah, it's increasing, but then we have that negative, so it's increasing to the left. So our smallest is obviously -3. So we'll have -3 here. And then our second smallest is -2.5. So -2.5 here. Then do we have any more negatives? Yes, we have -0.5 or -1 half somewhere here. And then we have 2 and the square root of 3. We know that square root of 3 is less than 2. And we know that this is 2. So I'm thinking that square root of 3 will come before 2 since it's less than 2. And we'll have 2 somewhere here. And now that we have this number line, like it told us to make, it's place the following on the number line in order from least to greatest. Well, we can, this is from least to greatest, so we can just order them like this. We have 2.5, -1 half, 0. Was 0 one of them? No, it wasn't, my bad. Square root of 3 and 2. And that's it. Thank you for watching the video.